Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 8 from the May-June 2023 International GCSE Cambridge 0580 Paper 4 Variant 2. And this question here is firstly about telling us that show that this equation y equals x minus 4 times x plus 1 times x minus 2 can be written as y equals x cubed minus 5x squared plus 2x plus 8. So basically what they're telling us to do is expand these brackets and write it in this form, simplify everything. So there's three ways we could do this. You could do, first of all, leave the x minus 4 on its own and expand these two in their own bracket. So you're going to have x squared. Now you can either do x squared minus 2x plus x and then minus 2, or you could use the pattern, because this is 1x, this is 1x. You can use the pattern where you can just add these two together and multiply them. So the middle term would be the sum, which is 1 minus 2, which is minus 1, so minus x. And the last term would be the product, which would be minus 2. Or you could do x squared minus 2x plus x, which would give minus x and then minus 2. Now this has to be expanded. Now please, what some people do is things like this. They write this, some people would write this as x minus 4, and then they won't put the bracket around the x minus 4, and they think that this means the same as that. It doesn't. This means the x is not multiplied by the bracket, only minus 4 is. This would be x minus 4x squared plus 4x plus 8. Okay, if you want to multiply the x with this bracket as well, you must put this whole thing in a bracket. Okay, so this is something that's very, very important. Somebody, I think, who asked me the question, multiply these two together first. I'll show you that in a minute. I'm going to show you the three ways. So this is x times x squared, which is x cubed. X times minus x, which is minus x squared. X times minus 2, which is minus 2x. When it says show that, and they give you the answer, you have to show the steps very, very clearly. Minus 4 times x squared, which is minus 4x squared. Minus 4 times minus x, which is plus 4x. And minus 4 times minus 2, which is plus 8. So you have y equals, now we can combine the like terms. You've got x cubed minus x squared minus 4x squared is minus 5x squared. Minus 2x plus 4x is plus 2x, and plus 8 at the end. And that's exactly what we had to show. Exactly the same. Now I'm going to show you another way of doing it as well. There's not just one way of doing it. Like you could, for example, have multiplied these two first and then the answer by x minus 2, in which case you would have got first x squared, then you have plus x and minus 4x, which is minus 3x, and minus 4 times x minus 2, in which case you get x cubed minus 2x squared. Okay, you finish with the x squared, now the 3x, so minus 3x. So again, before I go on to that, somebody wrote something like this, okay, in his working. This does not mean the same as this. This means the x squared and the minus 3x are not multiplied by this bracket, only the minus 4 is. So this would actually be x squared minus 3x minus 4x plus 8. Okay, now the person actually multiplied them together, but this is an incorrect way to write it. This does not mean the same as when you have the bracket around. When you put the bracket around the whole of this, then the whole of this is multiplied by that. So be very careful not to make that mistake. Okay, so this is x cubed minus 2x squared minus 3x squared minus 6x, plus 6x. Be careful, minus 3x times minus 2 is plus 6x, minus 4x, and plus 8. So hopefully this gives us the same thing. X cubed minus 2x squared minus 3x squared is minus 5x squared, and plus 6x minus 4x is plus 2x, and you're left with plus 8. So you see we get the same thing. Okay, and we could have done it also a third way. I'm just showing you all the different ways. Okay, you could have, for example, multiplied these two brackets first. So I could have done x plus 1. So I could have written as y equals x plus 1 times x minus 4 times x minus 2, and multiplied these two brackets first. So I'll have x plus 1. This would be x squared. Okay, this is a minus 2 here. X squared, and that's going to be minus 6x and plus 8. Okay, and then x cubed minus 6x squared plus 8x plus x squared minus 6x and plus 8. So you end up with y equals x cubed minus 6x squared plus x squared is minus 5x squared. And you got 8x minus 6x, which is plus 2x plus 8. So in each case, whichever way you do it, you get the same answer, because when you multiply three numbers together, all right, you can do a times b and then multiply the answer by c. You can do b times c, multiply the answer by a. You can multiply a times c and multiply the answer by b. You get the same thing. So this is basically, showing you you can choose any one of these three ways, but just be careful not to do things like, stuff like this. Okay, write things in that way. Okay, that's all. So that's part one done. Okay, so it's pretty simple, but you just have to be careful to show it properly. Now, part two, it says on the diagram, sketch the graph of y equals x cubed minus 5x squared plus 2x plus 8. Now, the reason why they gave us the question in such a way with these brackets is I know that this can be expressed in this form, which is going to help us. Okay, so we got to sketch a graph and indicate the values where the graph crosses the axes. So for any graph, whether it's a straight line graph, whether it's a quadratic graph, whether it's a cubic graph like this, okay, we have to identify a few things. So for a cubic graph, we know this is cubic because the highest power is x cubed. And we know cubic graphs either have this type of shape or they have this type of shape. If the coefficient of x cubed is positive, it will have this type of shape. Negative, it will have that type of shape. So we know that our graph is going to have this type of shape. So we should know and recognize it's going to look something like this. Okay, that's the first thing. Recognize the type of function we have and what the basic shape will be. So it won't be like this, it will be like this. Why? Because the x cubed, okay, has a coefficient, like you say, a is greater than 0. Coefficient of x cubed. The second thing we need to know is where does it cross the axes? So where does a graph cross the y-axis? Any type of graph, the same principle applies. It crosses the y-axis when x is equal to 0. So when we put x equals 0 in here, all these terms become 0. You're left with y equals 8. So it crosses the y-axis at the point 0, 8. Somewhere up here. Okay, I'm not going to mark it right now, and I'll explain to you why. Where does it cross the x-axis? Well, a graph crosses the x-axis when y equals 0, because along the x-axis, the y value is 0. The equation of the x-axis is y equals 0. The equation of the y-axis is x equals 0. It crosses the y-axis when x equals 0, crosses the x-axis when y equals 0. So when it's written in this form, it's easy for us to solve and find the values of where it crosses the x-axis. Okay, so you have x minus 4 times x plus 1 times x minus 2 equals 0. So either x minus 4 equals 0, in which case x equals 4. So it crosses one place at 4, 0. Or x plus 1 equals 0, in which case x equals negative 1. So minus 1, 0. And the other place was x minus 2 equals 0. That means x equals 2. So that's going to be 2, 0. So it's going to cross at, in order from lowest to highest, minus 1, and then at 2, and then at 4. That's where it's going to cross the x-axis. Okay, so we're going to make a sketch of this. Just make sure we did that minus 4 and plus 1 and minus 2. That's correct. Okay, good. Now, when we are going to sketch a cubic graph, okay, which we're going to do now, all right, what I suggested, this is what the student was asking, how can I improve my sketch? Because this sketch looked really weird. And the reason it looked really weird is because he marked the values on the axes before drawing the graph. Now, I'm going to get a general idea, and you should use a pencil to make sure, of course, that you don't mess up. It doesn't have to be 100% accurate, but it has to be things like the turning points have to be in the right places. So I know it's going to cross the x-axis in 3 places. One of them is going to be negative, and the other 2 are going to be positive. And the gap between these, between minus 1 and 2, the gap is 3. The gap between these is 2. So they're not too far apart. Okay, so basically, the gap between these 2 are going to be bigger than between those 2. It's going to cross once on the x-axis and twice on the negative side and once on the positive side. And it's going to go through the y-axis. Okay, so I know that the y-axis is going to be closer to 0. Okay, so it's going to be closer to minus 1 than 2. Okay, so it's going to be something like this. Okay, it's going to be something like this. It doesn't have to be to scale, Like if if my minus 1 is here for the x-axis, the 8 doesn't have to be up there somewhere. It doesn't have to be to scale, right? So I'm going to, as long as the 8 is somewhere on the positive y-axis, it doesn't matter. It really doesn't. So I'm going to make my graph something like this. I'm just going to draw a perfect cubic curve going like this, and turning up again. Right? So this is 8. This is minus 1. This is 2. And this is 4. Okay? It's not perfect. Okay? It doesn't mean to be perfect. It doesn't have to be perfect. Right? If these were equally spaced, it would be better. Okay? But no problem. I could have made it a bit less high, whatever, but that's fine. That will get you your marks. This is turning in the right place. Okay? Because the origin is closer to minus 1 than 2, so the turning point is like going to be somewhere close to halfway between minus 1 and 2, so it's going to be somewhere on this side, somewhere around 1. Okay, and it's cutting at the positive y-axis at a point on there. That's going to be our 0, 8. Minus 1, 2, and 4, they're all in the right place, and that's perfectly fine. So that's what I would suggest you do. Don't put the points on the axes first. Draw the graph first, and then put the points on the axes. Personally, I would prefer if they didn't even give us an axis. I would prefer if we just drew a cubic curve and then decide, okay, the x-axis has to be like such that on this side there's a bigger gap than on that side. So that's going to be my minus 1. That's going to be my 2. That's going to be my 4. And the y-axis is going to be closer to this side than 2, so it's going to be somewhere over there, and that'll be my y-axis, so that's going to be my 8. Minus 1, that's 8, that's 2, that's 4. If they hadn't given the axes, it's even better, but they give us the axes, so there's no need to worry too much. As long as you get it looking like it's kind of you don't want to have something like kind of like goes back on itself and does all sorts of weird kind of things. So that's why I would suggest you make the graph before you mark the points, but have an idea of how many points should be on each side and where should it pass through the y-axis, but draw it without forcing it to go through any points, and then put the points in. Okay, so that's some advice for drawing the graph. So that's how we sketch the graph of y equals x cubed minus 5x squared plus 2x plus 8. They gave us in this form so we can mark the intercepts with the axis, the x-axis. Okay, because we're using what's called the zero product property. If 3 things multiplied together to give you 0, one of them has to be 0. So either that's 0 or that's 0 or that's 0. So those are the 3 possibilities. So those are the 3 places where this graph will cross the x-axis. Okay, part 3 is on the next page. It says a graph of y equals x cubed minus 5x. Okay, so the graph of y equals x cubed minus 5x squared plus 2x plus 8 has 2 tangents with a gradient of 10. Has 2 tangents with a gradient of 10. Find the equation of these 2 tangents. Now, a tangent to a curve is a straight line which has the same gradient of the curve at that point. Okay, so there would be a gradient somewhere over here, for example, and somewhere over there. I don't know exactly where they are. I'm just drawing them randomly in places. But they'll both have the same gradient of 10, okay? And we want to find what those points where the gradient is 10 is, okay? No, the equation. We want to find the equation of those 2 tangents. So we need to find basically the equation of those tangents. Now, that means we need to find the points where those tangents touch the curve. Why? Because the equation of a straight line is found by 2 things. 1, by finding the gradient of those straight lines, and 2, by knowing a point on the line of those straight lines. Okay, so we already know the gradient of the straight line is equal to 10. Okay, because the tangents have the same gradient of the curve at the point where they touch them. All right, so the gradient of those 2 tangents is going to be 10, but we need to find the places where they touch the curve. So we need to deal with what's called the gradient function of this graph. Now, the gradient function of a graph is found by differentiating its equation. So we have x cubed minus 5x squared plus 2x plus 8. So we want to find dy dx, which is what you get when you differentiate this function. So you're going to dy dx is going to be given by 3x squared minus 10x plus 2. So that is called the gradient function. So we know that when the gradient is 10, okay, when the gradient of the tangent is 10, that means dy dx has to equal 10. So if I equate this to 10, the gradient to 10, so I have 3x squared minus 10x plus 2 equals 10, and I solve this equation, 3x squared minus 10x minus 8 equals 0, then solving this equation will give me the x values of the places where the gradient on the graph is 10. Okay, so to solve this, I think I can factorize this. I think you should be able to factorize it. I don't think it will give you like a difficult kind of third form number. So to factorize, I'm going to split the middle term in my own little way. 3x squared and minus 8 goes in these two boxes, the first and last term. I multiply those together, gives me 24x squared, negative 24x squared. I find two numbers, I multiply them together, and when I add those numbers together, I get, when I multiply them, I get 24x, minus 24x squared. When I add them, I get minus 10x. So they have to have different signs. One has to be positive, one has to be negative, because the product is negative. I think it's 12 and 2, right? So it's going to be minus 12x and plus 2x. When I multiply them together, I get this. When I add them together, I get that. Okay, that's correct. So now I can take out the common factor from these two terms. For example, 3x squared and 12x, it's going to be 3x, the highest common factor. 3x times this number should give me 3x squared, so this term must be x. 3x times whatever goes here, it must be giving me 12x, that must be minus 4. And x times whatever goes here must give me 8x, that must be plus 8. So our factors are x minus 4 and 3x plus 8 equals 0. X minus 4, that's wrong. What have we done wrong here? That should be 12, and that's a 2. That's what happens when you write. Very bad writing. Okay, that's a 2. Okay, let's just correct that. Be careful, be careful. That's supposed to be a 2 here. Okay, I put a 2x here. It's supposed to be minus 12x and plus 2x. So this is supposed to be a 2 here. So that should say 3x plus 2. Sorry about that. Okay, that's because my 2 looked like an 8 for some reason. Okay, but see, that's why it's good to check when you finished factorizing, check, does it give me that? If it didn't, I could see, so if there's 8 there, it should be minus 32 at the end. So there's something definitely wrong. So we realized, I wrote that 2 looks like an 8. So I wrote an 8 there instead of a 2. So it's always good to check your answers afterwards, like expand, see, does it give me this? So 3x squared plus 2x minus 12x, that's going to be minus 10x and minus 8. So we know for sure we're right now. So x minus 4 equals 0 is one possible solution, and 3x plus 2 equals 0 is the other possible solution. If these two products give you 0, that means x equals 4 and 3x equals minus 2, so x equals minus 2/3. So those are the x coordinates of the points, okay, where the gradient is 10, but we also need the y coordinates because we need, the points on the line. So let's see, for tangent 1, we know that x equals 4. To find what y is, we put it back into this equation here. So we're going to have 4 cubed minus 5 times 4 squared plus 2 times 4 plus 8. That's going to give me 64 minus 5 times 16, which is 80, plus 8 plus another 8. So you have, that's going to be 16 plus 64. 16 plus 64, that's 80. And minus 80 is equal to 0. Okay, so one of the points is going to be 4, 0. And funnily enough, I think when I drew one of them, I drew it exactly at 4, 0. Amazing, huh? Okay, that was a fluke. Anyway, so 4, 0 is one of the points where the tangent is, and the gradient is equal to 10. So that's one of the pair of values that I'm going to use. That's going to be for tangent 1. I can use that to find the gradient of the equation of tangent 1. And for the other one, we're going to have x equals minus 2/3. So let me do this up here so be a bit more symmetrical. So the other point, this is a long question here. Anyway, x equals minus 2/3. Now this, you're going to put into the equation, into the original equation. So you're going to have minus 2/3 cubed. This is going to be a bit more hassle to work out. Minus 5 times minus 2/3 squared plus 2 times minus 2/3 plus 8. Now, if you look at the symmetry of this, I'm pretty sure that will probably also be at one of the, that will probably also be on the x-axis. Let's just check. So you're going to have y equals, you can use a calculator for this, but I'm going to be doing this without a calculator just to practice for those students who are going to come later on who can't use calculators very soon in some of their papers. So you have minus 8 over 27. That's going to be negative because you're cubing it. This is going to also be negative, minus 5 times, and this will be positive because you're squaring it, so it'll be 4 over 9. Do it step by step. And that's going to be minus 4 over 3. Okay? Remember, you multiply it's like 2 over 1 times that, and then plus 8. So you have y equals minus 8 over 27. And we're going to have minus 20 over 9. Minus 4 over 3 and plus 8. We could use a calculator, but let me make everything over 27. So minus 8 over 27 minus, if I put this over 27, multiply by 3, that'll be minus 60 over 27. If I put this over 27, 3 times 9 is 27, 4 times 9 is 36. And I'm going to have plus 8. So that's going to be multiplied by, in fact, I'll just leave it as plus 8. That's probably be easier. And then whatever comes out there, I'll just add 8 to it and see what happens. That'll probably be easier. So we have here minus 36, minus 60, that's minus 96, minus 96 minus 8. That's going to be minus 104 over 27. So y is going to be equal to, what does that give us? 104 over 27. That doesn't give us anything, so that doesn't help. Let me just make sure. Let me just make sure I didn't do something silly. So let's put minus 2/3. It's minus 2/3. Yes, it is. So let's do this in case I made a silly mistake. Let's have minus 2 over 3 cubed. Okay, and you're going to have minus 5 times minus 2 over 3 squared. So bracket 2 over 3, close bracket, squared. And then we're going to have, let me sure I've done that correctly. It's going to be plus 2 times minus 2 over 3. Okay, so plus 2 times minus 2 over 3. Okay, and then we're going to have plus 8. Okay, that gives us 112 over 27, so I got something messed up there. Okay, plus 8. Yeah, so that gives us y equals 112 over 27. Okay, so yeah, that's correct. That's 112 over 27. So we have the other coordinates are minus 2/3 and 112 over 27, which is a bit of a horrible coordinate, and m equals 10. That's tangent 2. So let's find the equation of tangent 1 first. So I'm going to use the formula y minus y1 equals m times x minus x1. And I think you'll understand why I like this formula better when we're dealing with this question. Maybe it might make you realize, but both of them are fine actually, but no problem. So y minus y1, so you got y minus the y coordinate, which is 0, equals m, which is 10 times x minus the x coordinate, which is 4. So this will give you y equals 10x minus 40. So that is the equation of one tangent, okay? And the other tangent, we're going to use this coordinate. So we have y minus 112 over 27 equals m, which is 10 times x minus 2 over 3. So we have y minus 112 over 27 equals, we got 10x minus 20 over 3. Now we want to express the answer in the form y equals mx plus c. So we want to have y as a subject, so we're going to have y equals 10x minus 20 over 3 plus 112 over 27. When we add these together, it's like 112 over 27 minus, that's going to be 27, multiplied by 9, that's going to be minus 180 over 27. So 112 minus 180, that's going to be negative. Okay, that's going to be negative. That's another 8 to make it 120. That's going to be minus 62 over 27. Let's just make sure of that. So we have minus 20 over 3. Let's do it from here. Yes, minus 20 over 3. Minus 20 over 3. And plus 112 over 27. Okay, and that gives us minus 68 over 27. That's correct. Did I say minus 62? Minus 68, sorry. Okay, minus 68 over 27. So y is equal to 10x minus 68 over 27. Okay, all right, so there we have our two equations. Y equals 10x minus 40 and y equals 10x minus 68 over 27. Yep, okay, so there we have our equations. 7 marks for that. It's actually worth quite a lot of marks because there's a lot of stuff to do here. All right, so there's the answer to this question, number part B, number 8, part B. So this last question is a bit of a, a lengthy one, a bit of thinking involved, but it's something that is, understandable. You have to find the places on this curve where the gradient is equal to 10 to find the equation of the two tangents. So you know the gradient is 10. You have to then find the places where the gradient is 10 by differentiating, equating the gradient function to 10, solving, finding the x values, then finding the y values, and using them with the gradient of 10 to find the equation of the straight lines of the two tangents at those points. Okay, so that concludes this question. I hope that was clear. Thank you for watching. Other questions from this topic or from this paper can be found in the playlist that will appear in this section over here. Other question from this topic, which is comprised of, firstly, I would say sketching cubic curves. The first part is really dealing with all of that. And then differentiation. Okay, so those are the two topics that this involves. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.